Hi guys, this is Vineet and I welcome you to this video. The video topic today is Cardinality and Statistics in SQL Server. So this is a video on the performance tuning category. So I have prepared some videos earlier as well, so if you have not watched those videos, please go ahead and do so. There's a performance tuning playlist where you can find all the videos related to performance tuning. So today's topic is the cardinality and the statistics in SQL Server, and we will talk a little bit about data distribution as well. So before we proceed ahead, I would request you all guys to please go ahead and subscribe to my channel. There's a subscribe button below this video. Click on that subscribe button. It will give you a bell icon. Click on that bell icon. Select all notifications to get notifications regarding my upcoming videos on performance tuning and various other topics as well. So alright, so let's move ahead. Uh, Before you proceed ahead, there are some points to remember. Please watch this video till the end to gain better clarity of the concept, and if it's possible for you, please watch this video twice or as many times as you like until your concepts get cleared. Perform any exercises in your test and lab environments only. Do not touch any production environment or production databases. And we would like to know your thoughts regarding our videos, so please do share your comments, suggestions, feedbacks, any requirements, any day-to-day experiences with SQL Server. You may also talk about any of the situations where my content has helped you in some way. So please do share your comments. We eagerly wait for them and would love to read the same. Alright, let's move ahead. So guys, I've created some playlists for you to watch. Some of the common playlists are database design, tables, business continuity, indexing, performance tuning, integration services. And apart from that, I have Transact SQL playlist as well, which I have started few days back. And this video belongs to the performance tuning category, which already has more than 25 videos at present. And overall, my channel has around 210 videos, more than 210 videos. And my channel page link is given below. So this channel page link along with all the links for all the playlists mentioned above are given in the video description area. So please check the video description area out and you may visit any of the links as per your liking. So if you want to learn about performance tuning, please go to the performance tuning category and go to the performance tuning playlist and watch out all the videos. So the reason we create playlists for you guys is playlists are the better way to learn instead of watching videos randomly about each topic. So for example, if you want to learn about performance tuning, what we would suggest is go to the performance tuning playlist and watch all the videos from beginning till end. That's the better way to learn. For now, let's move back to the topic. So I hope you have subscribed by now. If not, let me give you 5 seconds so that you can subscribe. After that, I will move on to writing some notes and we will cover some practicals as well. So yeah, I'm waiting, giving you 5 seconds to complete the subscription. Alright, so I hope you have subscribed by now guys. Let me move on to notes quickly. So today's topic is cardinality and the statistics, and we will also talk about data distribution. So earlier guys, if we talk about earlier we had talked about the query optimization process and basically how it uses indexes, constraints and other objects within your database in order to figure out how to best satisfy the query. So I would say we talked about earlier we talked about the query optimization process, um, and basically how it uses the indexes and the constraints and other objects in your database to figure out how to satisfy your query. So earlier we talked about that, right? And basically we talk about all these objects including the indexes, constraints and the other objects and how the optimizer arrives at the estimated values. So basically all these objects in combination are how optimizer arrives at its estimated values. Alright, so it considers all these objects in order to come at some estimated values. However, if we talk, one of the single biggest driving factors in what leads the optimizer to choose one method of query behavior over another is row counts. So this is another important point. So the role of the query optimizer is to arrive at a particular plan, right? It produces a query plan. Okay. So if we talk about one of the biggest factors, so basically if we say optimizer choose one method of query behavior. So please watch out my previous video regarding the query behavior. So optimizer chose one method of query behavior over another is dependent upon the row counts. So in order for optimizer to decide which method to choose, which method of query behavior to choose over the another method, it depends upon the how many row counts we have. Alright. And if we talk about SQL Server, so if we talk about SQL Server, let me make it an next point. So if we talk about SQL Server, cannot count all the rows ahead of time. So SQL Server cannot count all the rows ahead of time. And basically for query optimizer to choose one method of the another required the row counts. And SQL Server do not have this data, row count data available ahead of time. Alright. And okay. So SQL Server cannot count all the rows ahead of time. However, if we say, so it doesn't keep a count of all rows ahead of time. However, it maintains information about the distribution of data within a column. So it keeps track of information of distribution of data within a particular column. It keeps track of that. However, it does not have row count information well ahead of time, right? And that basically this information, if we talk about, so information it maintains about the distribution of data within the column. SQL Server maintains information about the distribution of data within the column, and this information is called statistics. Alright, got it guys? So guys, statistics is basically the information about the distribution of data within a particular column is called the statistics. Alright, and basically if we talk about statistics, statistics are used to establish the estimates on row counts for the optimizer. So this information which SQL Server keeps about a particular column, data within a particular column, and which are basically known as statistics, and these statistics are used to establish estimates of the row counts for the optimizer so that it can make better decision on choosing the one plan over the other. Alright, so guys, we will discuss about some of the important points here. So let me list out that points what we will discuss in total. So we will cover the following topics guys. So we will cover the statistics in query optimization. So far I have given you general information about what statistics are, and basically statistics are used to establish the row counts which are used by the optimizer. Alright, but we will discuss in detail about how statistics are used in query optimization, and what is the we will also talk about behavior of statistics on columns with indexes. We will talk about that. So first we will talk about statistics in query optimization. Let me change its color, it's not looking better, and this is also not looking better. Let me choose another one. This one is better. So guys, we will first talk about the statistics in query optimization, how they are used, and then we will talk about behavior of statistics on columns with the indexes. Alright, what is the behavior of statistics? And we will also talk about statistics on the non-indexed columns when used in when these columns are used in join and any filtering criteria. So we will talk about role of statistics there when we use any when statistics are used on the non-index columns, and when these columns are used within the joins or any filtering criteria. Let me change the color again. I'm not liking this color actually. Let me took some subtle color maybe. How about this? Yeah, this one is looking little okay. All right. So we will also talk about the analysis of single column and multi-column statistics. All right, which will include the computation of selectivity of a column for indexing. So we will perform the analysis of single column and multi-column statistics, and it will include the computation of selectivity of a column for indexing. And next we will talk about how to maintain statistics, and at last we will talk about the topic effective evaluation of statistics used in query execution. Alright, so let's start with the first topic guys, and this topic will be statistics in query optimization. So let me copy this topic and let's start with this topic. Uh, let's remove the numbering pattern. This will be our heading. Alright, so this will be our heading, and let me change the font here. Let's check pink. Okay. So we all know that the optimizer, if we talk about the optimizer, it uses a cost-based optimization process. We are all aware about that. If you have not watched my previous videos, guys, please go ahead and do so. So in those videos we have discussed that optimizer uses a cost-based optimization process. Alright, and so it chooses the most effective or most good cost-based optimization process. So to summarize, the optimizer uses a cost-based optimization process, and thereafter, after choosing the best cost-based optimization process, thereafter optimizer picks the appropriate data access and join mechanisms by determining the selectivity of the data. Alright, and selectivity of the data, the meaning of the data, and how unique it is. Based on that, it picks the method for appropriate data access and the join mechanisms. Alright, and if we talk about the column in the select clause, so any of the columns used in the select clause. So let me make this a point. So any of the columns used in the select clause, let me make select bigger. So any of the columns used in select clause don't need any statistics. Alright, so these columns, whatever we used in the select statement, don't need the statistics. However, if the columns are used in the filtering mechanisms like the where clause or maybe if they are columns are used in the having and the join clauses, they must have statistics calculated on them. So the columns used in the select clause doesn't require any statistics. However, if we are using the columns in the where clause, having clause, or join clauses, these columns must have statistics defined on them or created on them. Alright? Alright. Now let's talk about a situation when an index is created on a particular column. We will talk about indexes later on. We will discuss them in much detail during our performance tuning video creation journey. We will cover them ahead. But for now, let's concentrate here. So whenever an index is created, statistics are automatically created. So whenever you define an index on the column, statistics get automatically created based on the data contained within the column or columns that define that index. So whatever columns are used inside the index, statistics are automatically calculated for those columns. If multiple columns are used for index, statistics are calculated on the multiple columns. So statistics will also be created by default on columns. So where else statistics are calculated automatically? Let's talk about that. So statistics will also be automatically created. So first they get automatically created for if we define any index on any particular column, they get created automatically. Statistics will also be automatically created by default on any columns that are not part of an index if those columns are used in any of the filtering criteria. So if any of the columns are used in the where clause or maybe having clause or the join clauses, statistics are automatically calculated for those columns. So these two are the main points where statistics get calculated automatically. So guys, I hope you are jotting down the notes. In case you are not jotting down the notes and that will require notes from me later on as a PDF format, that will be a paid affair. So if you need the PDF notes for the topic I'm teaching, the charges will be INR 25 per page. So if it's a 4-page notes, the charges will be 100 rupees for 4-page notes. And in order to get the notes, you need to send me an email on my email address vermavine@gmail.com. So upon receiving your request, I will send you the payment link, and upon making payment, you can download the PDF notes. But I would say the best way to learn something is to write the notes manually. Alright, as I'm writing right away, right? So alright, let's move ahead here. So far we were talking about on which column statistics get created automatically. Now if we have the statistics about data and the distribution of the data in the columns referenced in predicates is a major driving factor in how the optimizer determines the best strategy to satisfy your query. So in total, if we say optimizer determines the best strategy to satisfy your query is based upon the statistics calculated on the columns which are referenced in the predicates like where clause, having clause, and join clause. Alright. Let me write that down. That would be good for you. So once we have statistics, right, about the data and the distribution of data within the column. So once we have these statistics, which are for the columns that are referenced in the predicates, is basically a major driving factor. Let me correct it a little bit. So once we have statistics about the data in a columns that are referenced in the predicates is major driving factor in how the optimizer choosing the best strategy satisfy your query. So I hope you got this point. So once we have statistics available for any particular column or columns, and these columns are, if these columns are referenced by any predicates, including some clauses, where having, and the other clause is join clause. If these columns are used in the predicates or the clauses, it is basically a major driving factor on how optimizer chooses the best strategy to satisfy your query. All right. Now let me discuss the next point. So how does statistics help basically? The statistics allow the optimizer to make a fast calculation as to how many rows are likely to be returned by a given value within a column. Alright, so basically statistics help optimizer in calculating how many rows will be returned from a how many rows will be returned based on the given value within the column. Alright, so it helps in helps the optimizer in making the calculations. Now with the row counts available to the optimizer, right, the optimizer can make better choices to find the more efficient ways to retrieve and process your data. Alright, so based upon this row counts available, optimizer can select a better way or better choice to find optimizer can find the more efficient ways to retrieve and process your data when it has the row counts available. Alright, so if we talk about the default settings for your system and database, it will provide adequate statistics so that optimizer can do its job efficiently. If we talk about the default settings of your system, the default settings for your system and the database settings will provide the adequate statistics so that the optimizer can do its job efficiently. Alright, so default settings contain enough information to generate the adequate statistics so that optimizer can do its job efficiently. Also, if we talk about this default statistics maintenance, so let's talk about the default statistics maintenance. Alright, this will usually give the optimizer most up-to-date values within the statistics. Alright, so statistics maintenance happen at regular intervals, which basically provides the optimizer with the most up-to-date information within the statistics. However, you may have to determine if your statistics are being adequately created and maintained. So this have a clause. So however, you may have to maybe make sure, right, if your statistics are being adequately created and maintained. And in many cases, you may find that you need to manually take control of the creation and maintenance of statistics. So this is important thing. So in many cases, you may find that you need to manually take control of the creation and maintenance of statistics, and do not rely on the automated processes. Now this topic is done, guys, which was the first topic, statistics and query optimization. We are done with this topic. Now let me talk about the other topic. Just give me a moment, guys. So guys, let's discuss the second heading, which is behavior of statistics on columns with indexes. So let's talk about that. So let me copy that and put it there. We will change the heading a little bit. So we are talking about now the statistics on the column with indexes, or we can say row store indexed columns as well. Alright, so this is our next topic, and let's choose a different color now. Alright, so let's talk about statistics that are calculated on the row store index columns. So basically, if we talk about the degree to which a given index can help your queries run faster, right, is largely driven by statistics on the column, all right, or maybe columns in case index is created on the multiple columns that define the key of the index. So basically it depends upon the statistics that are calculated on the indexed columns, which basically determines how much your query will run faster. So it is determined by the statistics on the index columns. So let me rewrite the statements again. So write it in a simplistic way. So statistics on the indexed column or columns, whatever you like, basically determines how fast your query will run. So statistics on the indexed columns or columns determine how fast your query will run. Alright. So we calculate statistics on the index columns. Those give us very good benefits in running the queries faster. Now the optimizer uses the statistics from the index key columns. So if we talk about the optimizer here, the optimizer uses the statistics or uses these statistics from the index key column to make row count estimates. So the row count estimation or row counts calculation work is done by the optimizer, and in order to perform the row count operation, the optimizer needs the statistics that are defined on the indexed key columns, right? And basically this row count estimation drives the many of the other decisions, like how to access the data. So the optimizer makes use of these statistics that are defined on the index key columns to make row count estimations, and which will ultimately drive many of the other decisions like the access mechanism, etc., etc. Alright, okay. Now if we talk about SQL Server, it has two ways of storing indexes. So SQL Server has two ways of storing the indexes. Alright, so what are these two ways? We would say we have row store indexes and we have column store indexes. These are two types of indexes or two type of ways SQL Server store indexes, and we will cover them in detail later on. For now I'm not covering those, but yeah, I've just mentioned that SQL Server has two ways of storing the indexes. One method is the row store indexes, another method is the column store indexes. And if we talk about the row store indexes, so for row store indexes, if I would say, statistics are created automatically for any of the row store indexes along with the index, right? Whenever the index is created or a row store index is created, the statistics get calculated automatically on that column, and basically we cannot modify this behavior, so this behavior cannot be modified. Alright, however, you can add statistics to a column store index if we want, right? We got the idea. Like SQL Server has two ways of storing the indexes. One is row store and one is column store. And for row store indexes, statistics are basically created automatically along with the creation of the index, and we cannot modify this behavior as well. And basically we can add statistics to the column store indexes if we want. And if we talk about, if we make any changes in data, it can affect the index choice. So changes made to data can affect the index choice. So for example, I would say if a table has only one row for a certain column value. So if we only have just one row inside a particular column, right? So if a table has only one row for a certain column value, then using an index could have a great choice. Then using the index could be a great choice. So basically here we are talking about changes in data can affect the index choices. And for example, we have taken if a table has only one row for a certain column value, then using index could be a great choice. And if the data changes over time for this column and a large number of rows now match that value, it could be that the index becomes less useful at that time. Alright, and this is why we need to ensure that you have up-to-date statistics. Alright, so here we have taken an example where initially table has only one row for a particular column, and this row was unique as we only have a one row. Then using the index at that point could be a great choice. But if our data changes over time and we get multiple rows with the same value for that column, then index could be of little use, and we need to ensure that we have up-to-date statistics on that index columns in those scenarios. And by default, we all know SQL Server will update the indexes on your indexes, statistics on your indexes, as the index columns data changes over time, right? So yeah, we wrote that earlier as well. So by default, SQL Server will update statistics automatically on your indexes, or we can say index columns. So it will automatically update statistics on the indexes as the index or index columns data changes over time. So whenever the data changes over time on an index column, SQL Server automatically updates the statistics on that particular column. And we can disable this behavior if we want. So we can disable this behavior, this automatic behavior, if we want. Alright. So in order to disable that behavior, there is a setting called the auto update statistics is the setting. Alright. That can be changed to control this behavior. Alright. I will show you how to do that, but later on. Alright. And basically, if we talk about SQL Server, it uses the two methods for updating statistics. So SQL Server uses two methods for updating the statistics. Alright. If we talk about the default method, right, which is for SQL Server 2016 and greater. The default method for SQL Server 2006 and greater works well for most data sets where statistics are automatically being calculated as soon as the data changes, as often as data changes. So we are talking about default method here, which is in SQL Server 2016 and greater. It works well for most of the data sets. The algorithm that so there is an algorithm that runs in the background. So the algorithm drives the automatic update of statistics, which is the default method. and basically the algorithm that drives the automatic update of statistics, right, depends upon whether we are using the permanent table or a temporary table. All right. So guys, we were talking about how SQL Server uses two methods for updating the statistics. First, we are talking about the default method, which is the new method used for SQL Server 2016 and greater, and it works well with the most of the data sets. And basically, the algorithm that drives the automatic updates for statistics, depends upon whether we are using a permanent table or a temporary table. So let me create a table for you. So this table will basically show you how many rows should be updated before statistics can be calculated on that particular column. So what is the threshold for basically statistics update? How many rows should be updated in a column for the default automatic statistics update to occur? So let me quickly create a table here. Let's see how we can create that. So okay, let's create a 3 by 3 table or maybe 3 by 4 table for now. So let me properly create the table. I think this one is sufficient. This one is also sufficient, and let's drag the last column, right? Let's put some headings. So here we will take table type and let's expand a little bit on it. Second column will be number of rows in the table. How many rows are there in the table? And the last column is the update threshold for statistics update to, or maybe for automatic statistics update to occur. All right. So how many, the third column indicates how many rows should be updated before our automatic statistics update can be performed. Let me give it a different color quickly to this. Let's take a green color. All right. So if we take table type as temporary table, right? And if the number of rows in a table are less than 6, all right. So we have less than 6 rows in a particular column or in a table, all right. And the threshold here is 6 updates should occur before statistics can be calculated. So if we have less than 6 rows and 6 updates occur to that particular column, then it will trigger the automatic update of statistics. Now again, take a different situation where we have temporary table and rows are between 6 and 500. In that case, 500 updates are required in order for automatic statistics update to occur. Now let's talk about the permanent table where we have less than 500 rows. So in that case, 500 updates are required before the automatic statistics update process can trigger. So these many updates are required to that particular column values. One second guys, let me correct it. So 500 updates. Now let's talk about both the tables, both temporary and permanent tables. If we have rows which are greater than 500 rows, if any of the tables, whether it's temporary or whether it's permanent, if both can contain number of rows which are greater than 100, then a formula is used to calculate the threshold, and basically we take minimum of two values. So the minimum value is 500 plus, this is the formula guys, note it down. So 500 plus 0.2 into n, where n represents the number of rows in the table. Okay, so minimum of either this, or it will also calculate the square root of 1000 into n. N is again the number of rows. So yeah, this is the formula which will be used for calculating the threshold upon which the automatic statistics update process will occur. Alright, so let's move ahead. I don't know how to come out of this table. Let me see how I can manage this table. Okay, let's put some space there and then paste the table. Yeah, now it's okay. So basically here if we talk about n, so n basically represents the number of rows in a table. And if we talk about the last calculation, if the number of rows are greater than 500 in a particular table, right? So we will get a minimum of these two calculations. All right. So let me share an example with you. So let's assume we have a larger table with 5 million rows or 50 lakh rows, you can say. So if we have a table with 5 million rows, the first calculation, which will be 500 plus 0.2 into 5 million, so 5 into 10 lakhs, so 50 lakhs. So this will be the calculation, and the second calculation, so the first calculation, how much will it yield? Let me calculate that. So it will yield, so we do 0.2 into 50 lakhs. Let's calculate it. So it's equal to, oh, it has automatically calculated for me. Okay, that's fine. So the value comes down to this. All right, so threshold, first threshold is this for this particular formula. And basically if we talk about the second calculation, so second calculation results in a value of, we are taking square root of 1000 into n, which is again 50 lakhs. Yep. So well, calculation is done. So approximately I would say 70710 rows. So we got this value. So the minimum of these two values is 70710. This would then mean that data modifications to only 70710 rows will result in a statistics update. So this is the threshold for statistics update in case we have like 5 million rows. So this is the computation table, and this computation table is used for SQL Server 2016 and greater if we are using a latest compatibility model. Alright, so this is how the calculation is being done. So if we talk about the older methods, this one is the newer method of calculation. So if we talk about the older method of calculation, so we talk about the older method, which can be basically enabled by changing the database compatibility level, compatibility mode. And this method did not work well for larger data sets. So let's create another table. So calculations were a little different with the older compatibility model. So let me copy this table and I will slightly change the calculations which were being done under the older method. So rest of the items are same, but for the last row the calculation method was different. So it was 500 plus 0.2 into n was the calculation mechanism. It was not taking any minimum formula. 500 plus this. Alright, so if we talk about this older method, so with this older method, if we say more than, so with this method, how many rows will be inserted? It needs to be calculated, right? So this is the earlier calculation, right? So the earlier method was using only this formula. It was not using that another square root one and not taking minimum of that. So with the earlier method, more than this value, or more than these rows would have to be inserted inserted or maybe updated or maybe deleted before the statistics would update automatically. So we can see that the older method was little less efficient because it requires more of number of rows to be updated, inserted or deleted before the actual statistics update can be performed. This method doesn't works well for the larger tables with the larger number of rows or more number of rows, right? As we have just shown you the difference between the old method and the new method. The formula is slightly different for the rows where we have greater than 500 number of rows. The calculation slightly differs. Alright. So the newer method is slightly more efficient than the older one. Now as we can see, that would mean a lot fewer updates, therefore more out of date statistics. So if we have less number of dates less than this threshold value to this table, the automatic update of statistics will not occur. Alright. And basically we have an option, or we can make a choice to update statistics asynchronously as well. So this is another point apart from these calculations. So we can make a choice to update statistics asynchronously. So if we talk about the normal situation, which is synchronous update of statistics. So normally if we talk about when statistics need to be updated, query stops at that time. Query stops and basically waits until the update is complete to the statistics. So this I'm talking about the synchronous process here. So normally if we talk about the synchronous process, statistics need to be updated first. Until then, query need to stop and wait until the statistics get updated before query can execute further. But under asynchronous update, the situation is different. So statistics can get updated in the background. In the meantime, query can use the statistics which are already built. So query doesn't have to wait for the statistics to build under the asynchronous mode of building statistics. So let me mention that. So however, with asynchronous statistics update, the query will complete without waiting for statistics calculation to complete. The statistics will update, and then any other queries or any new queries using those statistics will get the updated values. With the asynchronous update, statistics update can still run in the background and the query can execute at the same time when the statistics are building, right? So query doesn't have to wait, it will run automatically and doesn't have to wait for statistics to build under the asynchronous mode of building statistics. And when the statistics are built, the next time the query runs, it will automatically use the updated value for the statistics. So far we have talked about the automatic statistics maintenance, right, which is the by default method. So whenever an index is created on a particular column, statistics get created automatically on that column, right? So we can also disable the automatic statistics maintenance. So maintenance is basically recalculation of statistics. We can disable these automatically statistics maintenance using the alter database statement commands, and we strongly recommend that you keep this enabled for your systems. So the recommendation is to keep the automatic statistics maintenance to be turned on. Alright, keep this to be enabled in your system. So recommendation is to keep automatic statistics maintenance process to be enabled on your system. Do not disable it. Although you can disable it, but don't disable it. So exceedingly, if we say fewer systems suffer from automatic statistics maintenance, the most systems benefit from it. Alright. And you can decide to turn on the asynchronous statistics update if you are seeing timeouts and waits caused by the statistics update. So let me also mention this point, which is important. So if we talk about largely few systems only suffer from the automatic update of or automatic statistics maintenance. Some systems do suffer, but those are very few, and basically most systems benefit from it. All right, and we can decide to turn on the asynchronous statistics update if we see that timeouts are occurring, and timeouts and waits caused by the statistics update. So if we see any timeouts happening because of statistics update or any waits happening because of statistics update, then yeah, we can enable the asynchronous statistics update at that time, so that statistics can build in the background and query do not have to wait for statistics update to complete in order to execute. And we'll talk about the alter database statement soon. So we are still in the second topic, which is the statistics on row, store, index columns. The third one is the statistics on the non-index column. So far we are talking about the statistics on the column with indexes. All right. So let me cover one more topic under this second topic. So let's talk about the benefits of the updated statistics here. Let me give it a different color this time. Let's take it as red. So what are the benefits of updated statistics? Let's explore on that. So let's explore how statistics update benefit the query performance. Alright. And in order to directly control the data in the tables, instead of using the AdventureWorks table, for this example, we will create a table for the test. So we will create let me take you through a practical where we will create a test table to check on this, whether statistics provide any update or not, benefits or not. Let's do that. So let's quickly create a query. You may have to write code along with me. So let's trigger SQL Server. So we will create a table with the name test1. So here we are practically seeing the benefits of the updated statistics. So I've triggered the SQL Server. Okay guys, we are inside SQL Server. Let's connect to it. We are connecting to the default instance. We will use AdventureWorks database, but we will not use any tables from there. So in this video we will explore how statistics update benefit the query performance. So what we are exploring, how the statistics update benefit query performance. And basically, in order to control the data directly in the tables, instead of using the AdventureWorks table, what we will do, we will create our own table for testing purpose. So let's create a table with a create table statement, and let's name it dbo.test1. And prior to that, just use the statement drop this table if it already exists, in case it exists from some previous practicals. Let me remove the table first. So if you use this statement drop table if exists, basically checks for the presence of table. If it exists, it drops the table. Now we are creating a new table altogether here, and let's give the table definition here, and we are taking two columns, C1 and C2. C1 will be integer type, and C2 column will be integer type as well, but this will be an automated column, which will be an identity column. So it will populate by the values in these columns are automatically populated. So this is my table definition. Now let me select one of the tables. I need to add 1500 rows to the table. So in order to do that, okay, let's expand on tables. I need a table with 1500 rows at least. So let's check the business entity one. Let's see if we have 1500 rows in there. let's check. We can use this one. So the table name is person.business entity. Yeah, it has 1500 rows, so we can use this to, not we will use the actual data, but we will use this to iterate through in order to fill in the 1500 values. So let me select top 1500, and I'm selecting not any data from any particular table, but instead I'm creating identity values, integer type, and I'm creating a column which will auto populate, right? Populate the values as I'm taking n is the column name, and we are putting these values into the nums table, right? And we are transversing the table personal.business entity. We can traverse any table, that doesn't matter, until unless it has more than 1500 rows, that doesn't matter. So let's select person.business entity. In reality, we are not using data from this table, but yeah, we are just traversing so that we can populate the 1500 top 1500 rows with the identity values. That's it. So first execute these statements. We will write the rest of the statements afterwards. So drop table if exist, execute. It is executed. Create table. A new table is created. I'm putting some 1500 rows into the nums column. Execute it. And we can select what is there in the nums table. So we can do select star from hash nums. So we have got n column with 1500 values. So we got 1500 values right here. Okay, let's move ahead. Now what we will do, we will insert the values into the table we had just created. So it's test1 we had created. Right now this table is empty. So if you do select star from tbo.test1, it will show you empty table with two columns, right? So what I'm doing is I'm populating this table. So, and what I'm populating, I'm not populating the C2 column because it is the identity column and should populate automatically, but instead I'm populating the C1 column. So let's select C1 into this. So I just want to populate the C1 column, and I'm selecting data to populate C1 column. I'm selecting n column from the nums temporary table. So select that, right? And let's populate that. Alright, so 1500 values are inserted into test1 table. We can check that. So the second column is auto populating, so it has automatically populated the volume values in the second column. So at the moment both the columns have the same values, right? And at this point we don't require the nums table, so let me drop it. So drop table hash nums can be run over here. So let's run this command to drop the nums table. Alright, so in the end what we are doing is we are creating a non-clustered index. So let's create a non-clustered index, and index name is I1 over here. Please remember the index name, it's I1, and we are creating it on the C1 column, right? So this table has two columns, C1 and C2. We are creating index on the C1 column. So let's mention the table name, which is test1, right? And we need to specify the column name on which we want to create this non-cluster index. So this would be the statement. All right. So let's execute this statement. So let me just go ahead and run a query where we want to select the, let's do a select query and run it with an actual execution plan. So turn on this button. So do a select, and first let's do select star from dbo.test1. This table has two columns, right? We are taking this table alias as t, and we are specifying where t dot c1 value is 2. We are filtering on that c1 column, and we want to select both column, otherwise we can select star as well, because this table only contains the two columns. Otherwise we can select individually as well, that's not an issue. So once we run this statement along with the actual execution plan, let's take the actual execution plan over here. So alright, this is executed and we have an actual execution plan. So there is only one row, right? And we have got this execution plan. So let's make a copy of it for later comparison. So let me copy this out, minimize it and keep it, right? Now the table is created and it is populated with the values, right? We have seen the execution plan. Don't want to save this query right now. Okay. So we have seen the execution plan. So execution plan contains inner join, right? And one row is returned, and then an index seek has happened on a non-clustered index I1. It was seek to fetch out the rows, right? Yes, some RID lookup was also done on the heap actually, as this is a table without a cluster index, so it's a heap. So this is the overall execution plan. I've taken a snapshot as well, and in this actual execution plan we see that the actual non-cluster index seek has happened instead of a table scan, right? There are no table scans, right? Okay. Now what we will do here is we will, let's close this. This is not required anymore. And what we will do at this point, we will use the extended event. So what we will do, we will create an extended event session here to basically do the work of profiling or tracing, right? So you can write code along with me. So this is a separate code. So in order to create an extended event session that will appear in this management section, you can do it via GUI as well, and you can watch out my previous video on how, and see how we can create extended plans in the GUI mode. So under management is a section for extended events, and under that we have sessions. So we create extended event sessions. So I'm creating a new event session via the T-SQL code. Earlier we had shown you how you can create extended event session via the GUI mode. So you can watch out that video as well if you like. Alright, so let me create event session, and the session name would be statistics. In my case, I'm taking statistics as the session name, and we are creating this session on the server, and inside the session we basically add events. So let's add an event. The event I'm taking is SQL Server .autostats. So this event basically refers to when the stats are built. So that's an autostat event where automatically statistics are built, right? And under that we specify the action for this particular event. So when autostats happen, we should see the SQL Server text, right? SQL text should be shown to us, right? So we need SQL text for any events where the stats are updated. Okay. Now action event, what action we need to take, or what action SQL Server should take when this event occurs. So it will add the SQL text to it, that event, and I need to specify that it should not take events for all the databases. So I need to specify for which database it should capture the event. So for that I can use the SQL Server.database name. Alright, and we can take the database name as here it is MyAdventureWorks. So let me take MyAdventureWorks here. So n should not be within the quotes. So n MyAdventureWorks. Alright, so this is the database. Let's just close it, and action part is closed, and I have to add another event, but for this event I'm not doing any action, just adding an event to capture, but I will not perform any action on this event, but it will just capture these events. So I want to capture all the SQL batch completed, so I'm putting it here. I put in the code, and we need to specify for which particular database that event should be captured. So I can copy this statement. I want to capture it for MyAdventureWorks. So this is done, and basically after event you need to specify the brackets. Alright, so statement should be within the brackets after the add event statement. So this is done, guys, and let's put a semicolon and put a go after that. So after I execute this, I don't need this code anymore. You can write it down if you like. So let me execute it. It will create an extended event session here. I can start the session right away. So in order to start the session, what I need to do is I need to write another piece of code. We basically alter the event session. Alright guys, so I need to start this event session. So I need to specify the session name, which will be statistics after the creation. And on server, basically this is the statement to for referring to a particular session on the server, and after that we need to change its state to start. So let's put start as state. So this statement will start the session, and the above statement will create the session. So let me go ahead and execute this. So I see, if you refresh the sessions now here, you will see statistics session and it is turned on. I don't need this code anymore, so I'm closing it. Session is created, right? So this session is currently on. I can stop it if I like, but it was started, so I can start the session whenever I like, right? So right now the session is stopped. So let's keep this session as off. In the meantime, let me insert some rows into the table. Let's insert the value. So insert into, I'm inserting data into table dbo.test1, and I'm adding the column into the adding the values into the C1 column, right? Okay guys, let's insert some values into this table in the C1 column. Let me insert the values 2. I'm inserting because it's an integer column. The values for the column C2 will get populated automatically, as that is an identity column. So let's execute this statement. So now we have two rows within the test1 table with having which are having values 2. Now at this point I would like to turn on the watch live data window to see the live events as soon as I run the queries. Now when I run this query, this one, right? When I run this query and along with the execution plan, right, the execution plan will still be the same. Alright, so let's check on that. So I've executed. If we take a look at the execution plan, I see that the execution plan is same because I've just inserted one row into the table, and what I'm fetching is data for two rows only is fetched, right? And only one row of data is inserted and two rows of data is currently fetched. So we see, and we can compare that the execution plan taken prior is almost same as the previous one, only there's a difference in the number of rows here, right? The rows are differing here. We are getting two rows, right? And same index seek is being done. Alright, so we just wanted to show you that the index plan is same, even though we have inserted one row and we have fetched data for a particular row with the C1 columns equal 2. Alright, so two rows got fetched and there is no change in the execution plan. If we take a look at the extended events here, right, we see is equal batch completed events, but we do not see any auto stats events, right, which we have configured in the extended session events, right? So there are no events which are showing auto stats. So stats are not calculated when we fetch the data, which is like two rows of data. Auto stat event was not triggered, right? So stats are not calculated on any particular column. And we can check this statement also on auto update stats, right? We have asked it to capture the SQL text. Otherwise it is not capturing the SQL text over here in the SQL text window, but a bash text is given over here. So this is the query that was executed, and I can take it to column as well, which is bash text. So this is the query being executed, bash text, and right now if I see no stats are counted here, nothing mentioned about statistics, right? So no auto stats event is triggered. So if we fetch just a small amount of data, it does not leads to update of the statistics, right? Unless the data is huge, right? Depending upon the number of rows in the table, the stats are not updated. If data is which is inserted is so small, like we have inserted just one row, or if the data which is fetched is too small, like we have just fetched two rows. So for small operations, stats are not calculated. This is what I'm trying to convey. All right. So let's close this window right now, the auto stats. We will use it later on as well. So there is no change in plan, and stats are also not calculated. Right, guys? You got this idea? So guys, we did not see any updates on the statistics because we adding a single row won't cross the threshold for statistics updates, right? All right. So the execution plan is same, and adding one row or selecting one row from the large number of rows present in a table does not result in the updating of statistics. So to understand the effect of data modification on statistics, let's try to add some more rows into a table. So right now this extended session is on, right? But we are not looking at live stats at present. So let me perform some additional operations. So what I'm doing is, table is already there, so I'm not dropping it or something. Let's copy this piece of code into another window maybe. And I need to modify this code little bit here. So I'm selecting top 1500, rest of the items are same. This is also same, and we can omit this. I don't want to check on this, and I don't want to select anything from DBO test 1. It has 1500 rows which we can see, but yeah, it's okay. I'm adding another 1500 rows to it, right? So I'm inserting into DBO test 1 in the C1 column. I'm again performing the insertion, but this time instead of selecting n from the nums, what I'm doing is just doing select 2 from nums. So what this will do, basically if I just plainly execute this statement, so num does not exist right now, right? So first we have to create it, right? So let's create the num table. Okay. So it has created a num table. If I just look at the star value for select star from nums, it will show me 1500 values from 1 till 1500. But I just want to populate the table with values too. So what I can do, I can change the star to 2. So if I change it to 2, it will just select 2 1500 times, right? So I will insert this 1500 times 2 data into the table C1. So let's do that, and let's insert it into the table, right? Execute it, and after that we can drop the table nums. That is not required anymore. Now a large number of insertion has happened, right? Now let's do a select, and this will result in large number of rows to be given from the 3001 rows that are present in the table now, right? So let's turn on the live statistics first. So watch live data should be turned on, and what I will do, I will run the previous query which was there in I will run this query. Alright, so when I run this query, now we have 1502 rows where the C1 value is 2, right? So we'll get 1502 rows out of 3001 rows, right? So now when we execute the select query, we are going to be retrieving a very large set of rows, which is 1502 rows out of 3001 rows. And since a large set is being returned or requested, scanning the table directly will be the preferable thing to do. Alright, so as we are, since there is a large result set being requested, right, it will return 1502 rows. So scanning a table at this point directly will be preferable instead of going to the non-cluster index. So a table scan is preferential at that time, at this time. if we are selecting the large amount of data instead of just a specific data. So index seek is not good here, right? So this is especially true since nested loop joins will, which we have seen earlier, right here. So this is especially true since the nested loop join will require us to access that index 1501 times. Alright, as we are fetching 1501 rows. So we need the query need to access the index, the non-cluster index 1501 times in case it uses the index. So ideally a table scan is preferential at that time. Optimizer should choose a table scan at this time instead of a cluster index, non-cluster index seek. Alright, as we are retrieving a large amount of data from this particular table. Alright. Now let's run this query with the actual execution plan on, right? So when we take a look at the execution plan, let's execute it. We will see a different execution plan this time because we are retrieving a large number of data. So optimizer should choose a table scan instead of a non-cluster index seek. So let's execute it, and we have also turned on the statistics. Now let's execute this plan. Alright, so we have executed it. We got 1502 rows here out of the 3001 rows, right? And if we take a look at the execution plan, now we see a table, the optimizer has chosen a table scan instead of a non-cluster index seek. Alright, which is ideal for this situation as we are selecting the large amount of data from the table, almost more than half of its rows, right? And if you take a look at the extended event session, here we see it has triggered the auto stats events, right? So these are two of them, right? So once which is saying loading and updating the DBO test, here it is building the statistics, and the event type is shown over here. It's auto stats event which got triggered because large number of rows are being retrieved from the table. So auto update stats event got triggered. So here it is saying loading and updating the index statistics for the index. All right. And the second statement is showing that the update operation has completed. So it has updated the statistics building on the index column on the DBO test table. So guys, you saw the difference when we select large number of data or less number of data from a table. The difference in terms of whether the stats will rebuild or not. So in the case a large amount of data is manipulated, stats get automatically rebuilt. But if we fetch or update or insert or delete a small amount of data, stats would get automatically updated. Alright, so we got this idea. And because we have updated so many rows, we exceeded the threshold. So earlier we told you about the threshold calculation here, how the threshold calculation is made on whether the auto update statistics should occur or not. Alright, so if we consider this table, the last row is applicable, so it perform these operations to figure out whether the update of auto stats is required as per this formula. Alright, so it calculates a minimum number of rows to be updated in order for automatic statistics update to happen. Alright, so please go through the theory part once again if you like, and go through the practical part once again in order to gain better understanding. Alright, so since we have updated so many rows, we exceeded the threshold. Threshold, we are talking about this threshold, right? This is the threshold column, and this was the formula which was applicable in this case, right? So it broken the threshold, and therefore the automatic stats update happened, right? Now we have told you about the threshold. So we have updated so many rows that we exceeded the threshold level, so the statistics were updated in this case, right? In this particular row, if we see, right? You can see that, okay. So we saw that statistics were updated, and we captured the column showing the statistics list. Alright, and the status from the auto stats event, right? So we got these two rows from the auto stats event, and we can see that auto stats were called twice. So we see calling this event twice, right? Once to load and update the dbo.test.i1 statistics, which is basically index statistics, and second time it was executed showing that those statistics were successfully updated, indicated by this column. So this is indicating that statistics are successfully updated for dbo.test.i1 index column. Statistics are built on the column where the index is also there, right? Alright, so second time the event got triggered, which is showing, second time it is showing that those statistics are updated. First time it started updating the statistics. And then the query ran, right? The statistics were updated, which resulted in a change to the execution plan. So after statistics are updated, this resulted in a change in the execution plan of the query from the earlier plan, which was this, right? Now the plan is changed after the statistics were built, right? So first statistics were built, then the plan was changed. Then the actual query execution started taking place. So statistics were updated, which resulted in the change to the execution plan, right? It now has a single table scan, right? This is a single table scan instead of a 1501 index seek operations. And this basically also illustrates why you want to test carefully if asynchronous statistics updates are desirable or not. The query should have run with the old execution plan. Fine, you got the idea between the difference depending upon how much data we select from a particular table compared to the number of rows present in a table, and it can result in the auto update of stats. Now let me talk about some of the drawbacks of outdated stats. So let's discuss on this. And before that, let me turn off that extended event session that is not required anymore. So let me stop the session. We have the old statistics. Let's keep it. But yeah, I've turned off the extended event session. Now let me get back to my theory part. So let's talk about the drawbacks of outdated statistics on any particular column, right? Let me make this a heading, the red one. All right. We are still under this section, which is the section 2. We are still discussing this in this particular section. Behavior of statistics on columns with indexes. So let's talk about drawbacks of the outdated statistics. So we just saw that statistics within SQL Server were automatically updated. So let me write that. We just saw that the statistics within SQL Server were automatically updated when we fetched large number of rows from the table. All right, as the threshold was reached. Threshold for auto stats calculation was reached, right? Now the updated statistics are then used to create a new better execution plan. So after the statistics were calculated, these updated statistics are then used to create a new better execution plan, right? So the statistics which were counted, which we had shown you in the SQL Server, and once these statistics were created, so this is the statistics were updated in this third row, right? It has shown updated. So the updated statistics are available at this point, and these statistics were used by the query optimizer to create a new better execution plan, right? Which was a table scan, right? So that basically illustrates the advantages of up-to-date statistics. By the time goes by, the statistics can become outdated. So as soon as time passes, statistics can become outdated. So if statistics are outdated, then the query optimizer, right, may make poor choices at that time if statistics are not updated on a column. So optimizer may make the poor choices that don't accurately reflect the data within the system. Alright, which will lead to bad performance. Alright, so if your statistics are outdated, optimizer will make poor decision and will create an bad query plan, which will lead to the bad performance. Alright, now we are going to demonstrate what happens when statistics are out of date. So we are going to demonstrate now what happens when statistics are out of date. So we will start from scratch here, right? So we need to execute some code once again in order to perform this. Okay, let's close this, and statistics is currently off. So we can use the same event session. But yeah, what we need to do here is let's close this as well. And from this code, what we need to do is there's a statement drop table if exists db.test1. So it will drop the table, and then it will create the table again, right? It will add 1500 rows to the table, and it will also create a non-clustered index. So it is adding 1500 rows. So first it adds the 1500 rows to a temporary table nums, right? Then it adds the 1500 rows from the nums table to the test1 table, and it then drops the temporary table nums, and it creates the non-cluster index I1 on the test1 C1 column, and this table has two columns, C1 and int, and the second one is auto-populated column, which is an identity column. Let me comment out some of the statement. I don't want to check them right now. So these two are not required, and rest of them are okay. And we can, for now, we can comment this as well. So let's see how to do that. Okay, let me execute it one by one. So let's first drop the table. So table is dropped. Let's create a new table with test1 name. I've created that, right? And at this time I can do a select from the test1 table, which contains nothing. Now let's create a temporary table nums and put 1500 values into it. So it is done, right? And we can check the data from the nums temporary table. It is just containing the values from 1 to 1500, right? Now let's put that 1500 values into that test1 table. Okay, let's execute this. This is done. All right, then we can drop the table nums as it is not required, and we can create a non-cluster index on the dbo test1 C1 column, right? Let's create an index. Index is created. So 1500 rows are there. I don't want to insert these rows anymore. So 1500 rows are present there in the dbo test table, right? Now at this point, what we will do, we will disable the statistics. Right now auto update statistics are turned on, so I will disable it using the alter database statement. So write that statement along with me. Alter database and database name is myAdventureWorks. For yours it may be AdventureWorks, so choose the database name accordingly. So I'm altering the database myAdventureWorks. I am setting the auto update statistics to off. Alright, so I'm turning off the automatic update of statistics. So execute this statement. Now the auto update of statistics is turned off. Now let's add the 1500 rows to the table as we were doing previously, though we have. Okay guys, I have copied some piece of code here from the previous query, these two sections. So let's create a new table here, nums. Right now it does not exist over here, right, in this particular session. This temporary table does not exist, so let me create that one with 1500 values, right? So we see 1500 values are now present in the nums table. But yeah, let me add just number 2 1500 times. So if I do this, right, it is selecting number 2 1500 times, and let me put this 1500 twos in the DBO test column quickly, right? So let me also turn on this session, right? Although I'm not capturing anything right away, I will turn on the live stats later on when we select the data. So let's insert the data first of all. I'm not capturing the insertion, right? And let's perform it with the actual, here actual execution plan is not needed. So let me just insert the values. So values are inserted. Right now, let me run this particular query which I had commented out, right? Uncomment this. I will run this query which will result in 1500 rows out of 3000 rows, right? And we can turn on the live stats right now to see the live data, and I want to run this query. So ideally if the automated or auto stats were turned on, then it will perform the auto stats operation as we are retrieving a large chunk of data, right? Now with this setup where the auto update stats is turned off, we turned it off using the statement, right? We ran the statement to turn off the automated stats when the threshold is reached. So this time the stats were not updated, and we will get the plan as we got before, right? We will not see any table scans, but instead we will seek the same, instead we will see the same plan as index seek, right? So this is the disadvantage of using the turning off the auto update stats, right? So let me show you quickly what plan it will generate. So I've turned on the automatic include the actual execution plan. So let's execute the statement. So when I see the execution plan, I see it is same as before, no changes, right? Same as before. And this time it has performed the index seek 1501 times. If you see here, it has seeked the non-clustered index 1501 times, which is not an ideal operation. Instead, what it should have done is it should have done the table scan instead of checking the index 1501 times, right? So this happened because stats were not calculated, as we can see from the live stats, right? We do see this auto stat statement here, right? So let's see what happened there. So auto stats event got triggered, right? But it is showing loading without updating. So it has not updated the stats, right? So it is loading the stats without the updating operation. So it has loaded all the previously calculated stats. It has not updated the stats, right? So as it has not updated the stats and stats are out of date, the next statement which is executed has resulted in this execution plan, which is not optimized, right? Now with that setup, we have ran this select statement, which resulted in an execution plan plus runtime metrics as shown here, right? And because the automated stats maintenance has been disabled, so it was disabled using this statement, the optimizer chose an execution plan based on the bad estimates now. Bad estimates of row count, right? As the automated update stats are off and those were not calculated, and those were it loaded the stats without updating those of them. So optimizer has chosen the bad plan, right? And we can readily see that in the execution plan where the estimated number of rows is 2 here, right? Where the estimated number of rows is 2 and the actual is 1501, right? Which is basically a 75050% variance, and that should not happen, right? You see the variance here. So we see that the estimated number of rows is here. The estimated number of rows here is 2, right? But the actual number of rows is 1501. So this is resulting in a huge variance of 75050%. And we should seek out these things in the execution plan. So the variances should not be that much. So that is resulting because of the out of date statistics, or statistics are disabled on the database, or out of date statistics on a particular column. Okay, guys, let's go ahead and also take a look at the differences in the performance metrics of a query when run under both statistics on and off. So let me go ahead and turn the auto update statistics to on quickly. So let's execute this statement. Now the auto update statistics are turned on. Now let me open up the query. I had saved it earlier, which we were working with. So let's open that query, and this time stats, auto update stats are on. So what I'm doing is I'm checking if test1 table exists, and if it exists, drop that table and create a new one with the same name. Let's execute that, and I'm adding 1500 rows with just numbers into the nums temporary table. Let's execute that, and let's add the data into the test1 table quickly. So I've added that, right? So after that, I'm creating a non-cluster index on the test1 table C1 column, right? Let's create the index. I'm not executing this query as of now, and already I have statistics extended session event created over here, extended event session, I would say, to be correct, created here. So I'm not creating that anymore. So here I'm inserting additional 1500 values into the same table test1, and these value will be 2, number 2, plain number 2 with 1500 rows. Alright, let's execute this, and after now this particular table test1 has total of 3000 rows, out of which we have 1501 rows with the number 2 in the C1 column. Alright, now we will execute this statement, but before running this statement, let me turn on the actual execution stats, and as the auto update stats is turned on, it should do a index table scan instead of index seek, right? So let's turn on the execution plan, and let's turn on the live stats, live data for the extended event statistics, and let's just execute the query. If we take a look at the execution plan, we see that table scan has happened, and if we take a look here, we see that auto stats events have triggered, and in the first event it has loaded and updated the stats on the index column, right? And the second one is the completion event, where it has updated the stats on the test1 index column. Alright, and after the indexes statistics were updated on the column, it completed the batch. Now if we look at the stats of this batch completed for this statement, which we executed right away, we see that the total number of logical read is 78. And if we, so first we take a look at logical reads, and we take a look at duration. So logical read is 78, and the duration is 104633. Let me convert, so it's in nanoseconds, so let me convert it here quickly. 104633, so it's equivalent to 0.10 milliseconds. In 0.10 milliseconds the query was completed. So these were the results when the stats were turned off. So let me take a screenshot. So I need to compare it with the automatic update stats turned off. So these are with stats equal to on. Let me note that down. So stats equals on. Alright, these are with statistics on. Only 78 logical reads happened, and query completed in 0.10 milliseconds. And now let's take the stats with the same stats with this option turned off. So let me turn off this option. So automatic update statistics, I'm turning it to off. So stats are off now. Automatic update stats are off now. Let me close this query, and let's reopen this query once again. So let's open it, and again I'm executing the same statements. It will drop the existing table and create a new one altogether, but this time the automatic update stats are off. So let's execute it. Let's select 1500 rows into this table, into the nums table, and add the rows from the nums table to the test1 table. So we have added 1500 rows, and we are creating the cluster index on the C1 column. Index name is I1. Alright, so index is created. I'm not executing this statement as of now, and I'm not creating the event session because it is already created over here on the left hand side. So let me insert additional values. Plainly I'm inserting number to 1500 times. Alright, so let's execute this statement. So this is done. Now the table has 3000 rows. Now if we execute this statement, it will select the 1501 rows from the set of 3001 rows, right? And before executing this statement, let me turn on the statistics. We are watching live data, and we need to make sure that actual execution plan is turned on. So we'll get the actual execution plan, right? And right now the statistics are turned off. So let me see the execution of this query. Let's execute. The execution plan we see here is non-optimized as the statistics are turned off. It's still doing an index seek over here, right? And if we take a look at the live data for the extended events, we see that auto stats event got triggered, but it was not completed, right? So it got triggered. It loaded without the updating. It started loading without updating the stats. Whatever data for stats is there, it loaded that. It has not updated the stats during the invocation of the auto stats event, right? So it has not updated the stats, and query got executed with the outdated stats data. And let's compare the stats here. So logical reads happened with the statistics turned off is 1535. Let's compare it with the stats turned on read. We see when the stats were turned on, actual logical reads happened were less. Only 78 reads were happened. Whereas where the stats were turned off, we see that 1535 reads were happened. So that's a quite lot of large number of reads happened with stats equal to off. With stats on, only 78 logical reads happened. And if we talk about the duration, with the stats on, the actual duration taken was 0.10 milliseconds. And for this, let me calculate 130538, 130358. I think this is the one. So let me quickly check. 130538, sorry. So 130538. So here it has taken 0.13 milliseconds, which is little bit larger if we compare it with the 0.10 milliseconds. It took 0.13 milliseconds. So we see query takes large amount of time to execute if the stats are not updated, and also logical reads are more if the stats are not updated, where if stats are on, we see less number of logical reads and less duration for the execution of the query. Alright, so number of logical reads and the duration are significantly higher with the out-of-date statistics we see here. The performance degradation and the difference in the number of reads are despite the fact that we are running the exact same query with the exact same result set. The differences in how the optimizers satisfy a query even when everything else being identical result in serious performance changes. Alright. So we saw the performance differences with stats on and stats off. We can compare these stats in the extended event session. For the batch completed stats, we can check out and compare these stats. Alright. So guys, we are done with this session. Rest I will cover in part 2 of this video. Let's go back to notes, but before we go back, let me close this. And by default, if we say that the automatic updates option is turned to on, so let's turn it back on before we proceed with the next session or next video. Let's turn it back on, and for now I'm stopping the statistics session. So we are fine over here, and we are done with this part 1 of this video. There will be more upcoming parts. So in this part we have covered up till 2 points. These points are covered. In the next video I will try to cover these 2 points, and maybe this video will get covered completely in the 3 parts. So far we have covered 2 points in this particular part, which is part 1 of this video, and the topic of this video is cardinality and statistics. So today we have discussed about cardinality and statistics. We discussed few points about that, and we discussed on few topics. We started with statistics in query optimization. What's the role of statistics in query optimization? We discussed upon that. We have discussed some of the points. You may have to go through that. And then we talked on the statistics on a row store index column, which is basically columns which have indexes on them, right? And apart from that, we have discussed about the threshold levels when the auto updates of stats get triggered based on the new compatibility level and based on the old compatibility level as well. We have discussed on when the automatically statistics update occur on a particular column in a table, and we have talked about that. Then we talked about the benefits of updated statistics, and we talked on the drawbacks of outdated statistics, where we have shown you some of the practicals to show the differences regarding the benefits and drawbacks. And yeah, that's it, guys. Please go through the notes once again and also look at the practicals we have performed in this video. In the next video, I will try to cover the points, statistics on non-index columns, where when used in the join and filter criteria. Alright, so we will talk about the statistics on any non-index columns. And we will perform the analysis of single column and multi-column statistics. Alright, including the computation of selectivity of a column for indexing. Alright, so we will try to cover these two topics in the next video. So stay in tune, guys. Do subscribe to my channel if you have not already done so. And in case you need the notes of this video, whatever is covered so far, you can send me an email on this email address, vrmavana@gmail.com. Notes will be on the paid basis. It's 25 INR for a page of notes. So if it's a 4-page notes, we are charging 100 rupees INR for 4 page of notes. And otherwise, I hope you have handwritten your notes to learn better. And once I got your email, do send me the topic of the video so that I am aware of what notes do I have to send. Once I get your request, I will send you the payment link, and upon making payment, you will be able to download the notes. So today we have covered the cardinality and statistics in SQL Server. This is the part 1 of this video, and it will require 2 more parts to cover this video completely or cover this topic completely. So stay in tune with us, guys. If you have not yet subscribed to the channel, or if you are new to this video and have not yet subscribed to my channel, or if you are an old user who have watched my videos in the past but not yet subscribed to my channel, please go ahead. There is a subscribe button below this video. Click on that subscribe button. You will get a bell icon. Click on that bell icon, select all notifications to get notifications regarding all my future videos. And guys, apart from that, do post in your comments use any suggestions, requirements, any feedback, any day-to-day experiences with SQL Server, or maybe you can let us know about the situations where my content has helped you somewhere in some way. You can also mention about that. And also, guys, if you have a good network of friends, please do share my videos with them. There's a share button on YouTube through which you can share my videos with your friends. And also ask your friends if they are working in SQL Server domain to join my channel or subscribe to my channel. I need this help from you guys to spread my channel, as I want to help as many people as I want. So I want to help many people. So need your help in spreading my channel. So please do help us here. I thank you so much for your time on this video today, guys, and you have a wonderful day ahead.